Evolution is the change in allelic frequencies in a population over time. When a population is at Hardy-Weinberg equilibrium, the frequency of the recessive and dominant alleles does not significantly change from generation to generation. The Hardy-Weinberg equation can be used to determine the expected frequencies of the recessive and dominant alleles in a population, as well as the approximate number of individuals that are homozygous dominant, heterozygous, and homozygous recessive in a population. Hardy-Weinberg equation: P represents the frequency of the dominant allele and Q represents the frequency of the recessive allele. Because P and Q added together represents all possible alleles for the gene in a population, P plus Q equals 1. P squared represents the frequency of homozygous dominant individuals, 2pq is the frequency of heterozygotes, and Q squared is the frequency of homozygous recessive. This makes the equation P squared plus 2pq plus Q squared equals 1 true.
In a population of horses, brown hair is dominant over black hair. If 27% of the population has black hair, what percentage of the population is heterozygous for hair color trait? For this problem, we are trying to solve for 2pq. To find this, we first need the values of p and q. Q squared is given in the problem as 0.27, so to find q, we need to take the root of 0.27, which is 0.52. To find p, we use the equation p plus q is equal to 1 and solve for p. When we do this, we get that p is equal to 0.48. To find the frequency of heterozygous individuals, we plug in the values of p and q for 2pq and get 0.4992, which tells us that 49.92% of the population is heterozygous, according to Hardy-Weinberg equilibrium.
For the next example problem, there are two different test lengths in a population of 209 elephants, long and short. Short tusks are dominant over long tusks. The frequency of the dominant allele is 0.38. How many elephants have long tusks in the population? So to solve this problem, we had to find the frequency of Q squared and then multiply that frequency by the population size. P is given in the problem, so to solve for Q, we use the equation P plus Q equals 1. Then we squared the value of Q to find out what the frequency of homozygous and recessive individuals was. We then multiplied this by 209, which is the total population of elephants. We got that approximately 80 elephants should have long tusks.
If the population is not evolving, it will remain at Hardy-Weinberg equilibrium. The allelic frequencies will not vary from one generation to the next if the population is not evolving. Also, when a population is at Hardy-Weinberg equilibrium, the equations can be used and will accurately reflect the real allelic and phenotypic frequencies.